There are so many interesting gems and tools that are being built in Ruby by the community. And today I'm going to convince to use one more. So we have numerous integration tests in our web application. And yet until recently, we were running them in Poltergeist, which uses PhantomJS underneath. Basically, there was a reason for that. PhantomJS gives you a full control of the browser. You're able to change headers, cookies, block or modify requests, responses, and so on. And it is headless. It is a perfect fit if you want to use it for crawling, but it has an outdated on 10 years WebKit engine. So if you want to run integration tests nowadays, you have three options. You can keep using Poltergeist, obviously, or use Selenium, or a secret weapon I'm going to talk about in my presentation. So Poltergeist is great, believe me. I've been a maintainer for years, but it's way outdated now, and I convince you not to use it. Selenium, well, requires installing additional software. It is slower than Poltergeist, and it doesn't give you full control of the browser. And Cuprite. Cuprite is a new gem that solves all the problems previous drivers have. It's faster than Selenium. There is no additional software to install, and you can do with browser whatever you want. I want to start with the contrast of Unix philosophy and web startups philosophy. So in the 70s, when Unix just appeared on the horizon, almost everything was headless. A binary you ran didn't have a visible UI. Or computers were headless too. Or they were displayless. Imagine how hard it was to write and debug program back then. And almost 50 years later, we still have to test every single aspect of our application that it works correctly with any given input. And now software is even more complicated nowadays. Unix philosophy was and still is write programs that do one thing and do it well. So the key is simplicity. Web startups philosophy, well, it's kind of different. Well, startup can evolve in so many different ways that we constantly have to choose which one is better. So the key is trade-off. No compilation, no static typing, automatic memory management make life easier and allow us to write very readable code faster, but still error-prone. So we have to write and debug our integration tests quickly, and we want them to run faster. PhantomJS was the fastest browser for tests. It was truly a headless browser, and it was so good in all aspects. Maybe the one downside was that you couldn't run browser in headful mode and watch your test passing. But you could take screenshots and check them one by one, or analyze log file. If you use modern front-end stack, chances that your site will look broken in PhantomJS are high. Forget about JavaScript 6, Flexbox, and latest frameworks. Schematically, there are two processes communicating by WebSocket. Poltergeist spawns PhantomJS, which sets up the WebSocket server where we can start sending comments to. What could go wrong? Well, in 2017, Google announced Chrome supporting headless mode right out of the box. And this was an end for PhantomJS. We could start using Chrome for headless testing, writing crawlers, checking performance, collecting other useful metrics, and so on. So this is the browser our end users use, and no matter what feelings you have for Google, it's 70% of the market, and it's really performant and well-suited for our job. Headless or headful Chrome is absolutely the same browser. If we run it with headless flag, the process will be started without any visible window. We can connect to the given port and start talking to the browser. So here on the slide, I picked up port number 9222. If you make an HTTP request to the given address, besides some short statistics about the browser, the most important line for us would be WebSocket debugger URL. As you've noticed, all communication happens to be going through the WebSocket, and WebSocket is a protocol that is language agnostic. So it is implemented in many, many languages. We can send JSON to the given address, but in order for Chrome to understand our comments and us understand Chrome answers, we need to come up with a different protocol over the WebSocket. And there is one called CDP. So CDP stands for Chrome DevTools Protocol, and it's not something new. You, by the way, have already used it in Chrome's inspector. It's how inspector works underneath. So run Chrome, connect to the given port, and start sending and receiving comments. Here I should say that browser can have a few WebSockets. One goes for the browser itself and supports a limited amount of comments that are related to the whole browser. The others are created for each page or tab. So basically that means we can operate each page independently. In general, CDP is a simple protocol. There are many domains that group comments together, and each domain has its own purpose. On the slide, you can see page navigate comment and Chrome's response. A comment is a simple JSON which consists of the method or comment name and some additional params. It also has a unique ID. Chrome response has the same ID and some data regarding the command. There is, for instance, another domain network. Chrome sends you notifications on events sometimes, and it can be opened windows, dialogues, network request interruptions, and so on. There are many of them. On the slide, you can see an event Chrome sends when it is about to make an HTTP request to the given address, as the name request will be sent suggests. So basically, everything you see in Chrome's inspector can be implemented using CDP. And as we all know, inspector can do a lot. So enough of CDP, let's switch to Ruby world. So Ferrum is a Ruby gem that controls Chrome through the WebSocket by CDP protocol and provides you higher level API. There is no additional software required. Just blend half Ruby, half Chrome, and you'll get Ferrum. This is an exciting mix, no addiction. So if you're familiar with Puppeteer on JavaScript, the idea is the same, but it's not 100% compatible. So here on the slide, we launch the browser, create a new page, make it go to example.com, then we take a screenshot and close the browser. On Ruby, it looks much simpler and more concise, but we still do exactly the same scenario. There are a lot of features already supported regarding navigation, finders, screenshots. You can even intercept network traffic, stop responses, use basic authorization. You can click around with mouse and send keyboard events. Those that are not distinguishable from real ones, like a real user would do. You can work with headers, cookies, JavaScript, dialogues, and so on. In fact, we already use it in production for crawling purposes, where, as you know, you have to pretend to be a real user in order to bypass some defense some sites use. So Ferrum was written to be fully thread safe from the beginning. And you can work with dozens of open pages at the same time from the same process using multiple threads. Each page can be maintained independently through WebSocket. In the code above, we create a context. A context is a Chrome feature. It's like a brand new profile, like an incognito mode. Once you close it, everything is gone. So create one or a few contexts and one or a few pages in the context and work with them simultaneously. So now we know what Ferrum is and how it works. Let's move to the next gem called Cuprite. Cuprite is a Capybara driver which uses Ferrum underneath. Basically, it makes Ferrum to be compatible with Capybara calls. So for example, Capybara has visit method, but Ferrum has goTo. So basically, Cuprite fulfills the role of the adapter. Another important thing I'd like to point out is that they work differently. Ferrum is higher level than what CDP provides, but it's lower level than Cuprite. It doesn't have, for example, fill-in or click-link methods because it's not just one simple action. As you know, in order to set input field, we have to click on it or give it a focus like real user would do. Then we have to select all the already typed text and then delete it and type new one. In Capybara and Cuprite, it's all done in just one call fill-in. So everything is hidden from the developer in this one call. The same logic applies to click-link. So click-link is not just one action. It's at least 2 or maybe 3. So first we have to find that link, detect link's coordinates, and if link is not in the viewport, then scroll page down and only then click. So Cuprite is almost fully compatible with Poltergeist with some minor changes. In our application, these are the only changes we've made in Spec Helper, but I cannot claim that for you it will be as easy as for us. Sometimes people email me log files and I help them to debug tests after the switch, and usually the reason for failing test is not the new driver and Cuprite, but test itself. So Cuprite works faster than Selenium, and you cannot notice your flaky test before switching to the new driver. So this is classic. Now I'll tell you about top mistakes and misunderstandings people still have while writing integration tests. So top issues. So first, what synchronize is and why we need it. Imagine like you are a browser. You went to some example.com URL, you grab HTML, you parse all the tags, and then you figure that you need to make additional requests to get CSS and JavaScript resources. Once you did that, you ran some JavaScript. So the question is this the moment when you can tell that, OK, now the page is fully loaded? I think the closest would be when you grabbed all the resources you need, when JavaScript is idling and there are no pending network connections. But I think it's doubtful in modern web, right, with WebSockets and stuff. So the same problem Capybara and JavaScript driver have. They can tell for sure that, OK, this is definitely the moment when we can start interacting with the page. The only thing we can do is guess. So synchronize helps you to determine if there is something or there isn't on the page during some amount of time, so that we constantly have to check in a given amount of time for this condition and then give up or succeed. So the key for reliable tests is to use weighting matchers. This is like, to your surprise, but weighting matchers with they have been long with us, and people still have the same mistakes. Another thing that I like to point out is sometimes weighting matchers don't work just because after some click you don't change DOM, but you cannot proceed right after the click because it will be too soon. So we used to have something like wait for Ajax in our code base, but the way how it was implemented, it was using JavaScript and jQuery. So we were basically checking with JavaScript if there are active jQuery connections. But now with Cuprite and Chrome, you can only use pure Ruby version of it, wait for a network idle, where Chrome streams all the events regarding network right to Ruby. So we have everything we need in Ruby. So you don't even need JavaScript now. So if you have animations, just don't forget to turn them off. In Chrome, you can also do it natively. And another important thing that I'd like to point out as well is that people waste too much time for inefficient debugging of integration tests. So with Cuprite and Chrome, you can now switch Chrome to a headful mode. And if your test is passing too fast, you can even add slow more flag. And all the comments that we send to Chrome by CDP protocol will be delayed on that value. So basically, you can see your test passing right in front of you in a slow more mode. Another thing is logs are scary at the first glance, but you just have to use to them. This is the only way to find and figure race condition in tests. So there are a lot of things that are going on inside the browser. Chrome sends a lot of events to you, and there are a lot of not that readable comments in the log file. But the only thing is just get used to it, and it really helps me to debug race conditions in integration tests. And finally, you are free to put debug method, statement method, in any place in your test, and then the test will be frozen in time, and we will open Chrome with an inspector, which will show you the current picture of your web page where you put the debug statement. If you put binding argument to the debug method, path, sorry, instead of pausing the test, we will open RB or pry console, and this basically means you can write your test incrementally, checking everything right in console and seeing the results in Chrome. So to sum it up before we move on, the zoomed out picture would be two processes, again, communicating by the WebSocket. One is a Chrome process that accepts the connections, and the other is Ruby process that sends comments by CDP protocol to it. This pretty much resembles the poltergeist schema that I showed before. So let's see how Selenium works. This is my favorite part. There's another protocol called WebDriver, which allows you to also drive the browser, but it's been in draft like since forever. So before you can start giving orders to the browser, you have to start one more external process. And basically, it's called WebDriver. Each browser has its own WebDriver. So for example, for Chrome, it's Chrome driver. For Firefox, it's Gecko driver. So instead of sending comments right to Chrome, you now have to send HTTP requests to the WebDriver. WebDriver determines the number of steps it should do and sends them back to the browser. Then browser does what it needs and sends back response to WebDriver, which sends HTTP response back to you. This is kind of quite a long way, really. OK. So the main advantage of such approach is that you can swap the browser. So instead of, say, using Chrome, you can switch to Safari. But remember that you have to install additional software for each browser if it doesn't come with a browser. Honestly, but it's the only advantage I can think of, because besides that you need one more external process, this protocol is very limited because it needs to support a wide range of browsers. So for example, if there is a feature to intercept network traffic in Chrome, it may or may not exist in WebDriver. It doesn't exist. So with another long-awaited feature to modify headers in WebDriver. And passing data back and forth through another external process also comes at a price. As we all know, HTTP is a unidirectional protocol, and the request is initiated by client. WebSocket is bidirectional protocol, so that basically means that Chrome can stream all the events that are happening inside the browser to you, and you are able to catch them. In case of WebDriver, you don't have such ability. Yes, I'm looking at you, WebDriver. So you're dying hard. CDP, if we compare it with the WebDriver, just popped up on the market. But many browsers nowadays are based on Chromium and Chrome. So like I said, it's 70% of the market. There's Firefox, but for your surprise, it also supports CDP. In fact, there's another repository that shows is it ready for Puppeteer. So in fact, it was like 80% coverage, so it passes almost all the tests. So in fact, Firefox also supports CDP. And if we take a look around, it turns out that CDP kind of wins now and is the future for at least 21st century. Maybe it can last even longer, who knows? So I understand that rewriting and changing driver for existing project is a huge pain. but at least start a new project, try to and choose a proper driver. Thanks.
So, any question?
You should have them.
Did you try to migrate a test suite from Selenium or WebDriver to Ferrum? And
Yeah, I didn't hear the first part. Migrate what?
did you already migrate a test suite from Selenium to Ferrum? And what was the benefit in performance?
Yeah, so like I said, in our project, we migrated from Poltergeist to Cuprite, and it was relatively easy switch. I helped a friend of mine to migrate from Selenium, and as you know, if you use something like Manage or something in Selenium, when you need to work with cookies and headers, this is the only problem. They also, like I said, he asked me a couple of times, like, it doesn't work. Our tests are failing. And the reason was that, basically they didn't use weighting measures. That was the reason. So basically I helped them to write tests properly. So that's all. Yeah. So it's also relatively easy, but it depends on the project. Nobody? Oh, okay.
What were the performance differences between Selenium and Cuprite?
Selenium and Cuprite? Right?
Yes.
Oh,
Yeah.
okay. I was waiting for such a question, but in terms of Poltergeist, I thought. Well, I cannot say because, like I said, in our test suite, we were using Poltergeist. So for our test suite, Poltergeist locally on my machine was working for 9 minutes. When I switched to Cuprite, it started to run for 17 minutes. But basically, is it working? No? Yeah. Okay, sorry. But basically, when you run tests in parallel on CI, the difference was just only 2 minutes, 1 or 2 minutes between Poltergeist and Cuprite. For Selenium, I have no such data, but a friend of mine again says that it was way faster, like 5 minutes or so. Not exact, number, but kind of.
Are there any things that you can do in Selenium that you can do in Cuprite?
Could you please repeat the first part? Anything that I can't do?
Are there things that are not possible in Selenium, but that you can do in Cuprite?
Ah, okay, I see. Well, actually, a lot of things. Like I said, we not only use Cuprite for headless testing, we use it for crawling as well. And as you know, for crawling purposes, you have to bypass defense some sites use, and this includes running some JavaScript. This includes modifying headers, removing cookies or setting our own cookies. So nothing is supported by Selenium right now. I think that for cookies or headers, I'm not sure, but you have to install third-party gem or something that will allow you to do that. But again, in case of Chrome, this is done straightly by CDP protocol. So there is no reason to, for me, there is no reason to use WebDriver at all, and Selenium as well.
Thank you.
Okay, no more question.
Thank you.
Thank you.